Friends, in today's class we are going to discuss the static polymorphism, which include function overloading and operator overloading. Till last class we have discussed what is the benefit of a polymorphism, and polymorphism is one of the important pillar of object oriented programming out of other pillar which include inheritance, data encapsulation and data abstraction. In today's class we are going to discuss various examples with running the program of a function overloading, which is a static polymorphism. As we discussed, polymorphism are of two types: static polymorphism and runtime polymorphism. Static polymorphism is otherwise known as yearly binding or compile time binding, and runtime polymorphism is known as your late binding or dynamic polymorphism. And first technique of static polymorphism is function overloading. What is function? As you know, function is a subroutine, provide modular approach, gives the concept of reusability. Reusability means write once and run many without writing the definition again and again. And what is the feature of overloading? The answer is the name of the function is same, but they may change with their parameter and the return type. What is the benefit of a function overloading? We have not to take the maximum space. As you know, as much you take the different function names or any identifier as the variable, that much space is taken. If you take a single function but they will change with its parameter, then with the less space we can do maximum, which increases the performance of the program. As you know, if the space is reduced, the time is reduced. If the space increases, the time increases. And the computer point of view, we must need that how much less space it will take to run our program. Hence, the definition tells the process of having two or more functions with the same name but a different parameter is known as your function of overloading. The function is redefined by either its different types of argument or number of argument, because function with its parameter may be changing its nature on basis of type or number of a parameter. It is the only differences that a compiler can differentiate between the function at the time of running the program. The advantage of function overloading is that it increases the reusability of the program, because you do not need to different function name for the same actions. With the function overloading, multiple functions can have same name with a different parameter. You can see it. Main function, main function, main function. Name of the function is same, but the parameter is different. It is user-defined function. My function is not predefined. You can take as Sriram, Shreyansh, my child, whatever the name of the function is user-defined, you can take. The first function, my function, takes integer. My function takes second function is the same name, is carrying the float, and my function as the third function is takes the double type, means the type or the number of argument might be changes with its return type. Here integer, here float, here double, or some extent you can take as a void. Take the example here. You have taken plus function int is a user defined function which carries two integer. Plus function double, you have taken another function with carrying two double. This is not function overloading. So why we are distinguish with the function overloading? Because suppose plus function takes 2 bytes, then plus function double it also takes the 2 bytes. But we want the name of the function is same, but the parameter is different, means not taking 4 bytes, we take 2 bytes, but we will be executing the same thing. That is the main benefit of the function overloading, so that we are comparing with a normal function and the function overloading. Now you see, if you call plus function 85, what will be called? It will receive in x and y, and value will return x plus y, that will be stored in the mynum. If you call plus function double 4.3 6.26, it is receive in plus function double user defined function, receive two values and return the values. Then we have to access these values. But this is not function overloading. This is only the function calling, but taking the extra space in the memory. And hence, if 8 and 5 will return as the sum, it will display 13. If 4.3 and 6.26 will be called, it will return the value 10.56. If you want to run this program, go to your turbo compiler. I have written the same program, you can see it out. and compile it and run the program, you will be getting the result that much what we have represented in the slide. But this is not function overloading because you have taken two functions, plus function int and plus function double. In the next example, we are discussing how real function overloading works. Now you see, we have taken plus function carries two integer argument. We are taking plus function. Name of the function is same, but parameter different because we are taking two double. Hence, instead of taking 4 bytes for each function, it will take 2 bytes as example for both the function. Means no extra space will be taken for the each individual function. Here, if plus function 85 will call, compiler calls the integer base argument as 2 integer and return the value. If you call plus function 4.36.26, it is the point value as the double argument base function will call, because the function changes in the terms of your what? The parameter. Here it is integer, here is double. Two double values, sum will be returned and stored in the my num2. If I access it, it will display the value of integer sum and the value of a double sum. If I want to run this program, moves to your turbo compiler. Let me to open. First you see, same function name is taken but the argument changes. Then if I want to compile it, first compile it, then run. You will be getting the result accordingly. If I want to execute step by step, I can also execute it. You can see it out. Integer will then will call, then it's going to call what is in the will and terminate from the program. The third example is taken how. In the previous example, we have taken two integer and two double. Here, we want to vary in the terms of number of argument. Here you see, we have taken add as a user-defined function takes two integer, add as a user-defined function three integer. Means type is same, but the number of argument is different. Here two integer, here three integer. Why it is static? As we know, static function never required any object to be called. It can be called directly. So you call it by the help of object or directly. Call object c dot add 1020. It will call this function and return a plus b. Again c dot add 12, 20 and 30. What it will call? It will call three integer base argument and return the value. Means in two way we differentiated, either in the type will be varied or it will be varied in the terms of number of argument. If I want to, if you run the program, you will be getting the result accordingly. I want to run it by the help of your turbo compiler. Let's close the previous program and open the next program, but I have previously written. See, same program is written. Compile it. Now run it. You will be getting the result accordingly. In this way, in today's class, we discuss how function overloading work as a static polymorphism with three different examples. I think today's session is essential to you and you understand. Having any doubt, please make the comments. If you like the video, kindly like it. If you have not subscribed previously, kindly subscribe it. Thank you. See you in the next class with operator overloading.